Hi everyone, and welcome to this video on the dynamic firms problem. What we're gonna do is we're gonna discuss how the representative firms problem looks like, and how to calculate for the dynamic profit function of the firm, how to find their optimal labor demand, and also the relationship between the firm's problem and the real interest rate and how much they choose to invest. If you look at this first problem, we have that the representative firm's production function is given by AT, KT alpha, and T1 minus alpha. So you have KT representing capital stock and NT representing the labor hours. And AT is some technological scale. But for this problem, we suppose that A is equal to 1. Okay, so that scale is just sort of like a constant scale. And we're given that the initial level of capital is K1 equal to 1. Okay, and we have here the fact that the representative firm exists for 2 periods. So it's a simple dynamic model that we have here. And we also have that the wage rate is WT equal to 1. And we also have that alpha is 0.5. So let's first solve for the dynamic profit function of the firm. And actually, I'm not really solve, but actually write it down. And it just basically looks like a normal profit function when you have the revenue minus plus any capital left over, capital gain, less the cost of obtaining capital and labor, plus the less further the discounted profit, dynamic profit on the next period wherein you have the wage and you have the capital. So it's very simple. So say P1 is the price in period 1, and you have a P2, which is the price in period 2. Okay. So to solve for the dynamic profit function of the firm, so that's just P1 times A1, K1 alpha, and 1 minus alpha. So that's like total revenue in the first period, plus the value of the capital that the firm initially has in the first period, normalized by the price, okay, minus, okay, P1, okay, N1 W1, that's the labor cost to the firm, right? So the price times N1 W1, right? Minus P1 K2, that's the cost of obtaining new capital for the second period. Again, the firm makes a decision on how much capital stock it chooses to obtain in one period, the past period, right? So then, okay, we have the profit of the firm, right? In the next period too. So this is just period 1 profit. So that's a period 1. We need period 2, and the period 2 is gonna be P2 K2. Again, the value of the undepreciated capital at that period, plus the revenue P2 A2 K2 alpha N2 1 minus alpha, right? Minus P2 N2 W2 minus P2 K3, right? Assuming that there will be some K3 term there, but because the firm only exists for 2 periods, that K3 would be 0. And because this occurs not in the present, right, it's a dynamic problem, we have to discount this second period, okay, by an interest rate. So we have to divide by 1 plus I, right? Then, of course, right, we can rewrite this. Without the prices, right? So we can normalize the price by a numeraire procedure. And what we're going to get is A1, K1 alpha, and 1 minus alpha, plus K1 minus N1 W1 minus K2, plus A2 K2 alpha, N2 1 minus alpha, plus K2 minus N2 W2 minus K3, divided by the real interest rate in this case, which is 1 plus R. Okay, so that's the dynamic profit function of the firm, and that's the answer for A. Okay, Letter B is sort of simple. It's sort of asking what's the optimal demand of labor in period 1, and that's a simple proposition. Well, to find the optimal labor demand, okay, what we do is we use the first order condition, which states that the marginal product of labor should be equal to the real wage. All right, so what we're gonna have here is, you remember, our production function is AT, KT, alpha, and T1 minus alpha. And in period 1, because we're looking for period 1's here, period 1's optimal labor demand. So this is going to be A1, K1 alpha, and 1 minus alpha, right? So what we're going to do is we're going to derive this one with respect to n. And what we're going to get is a 1 minus alpha, A1, K1 alpha, and 1 negative alpha equal to W1, right? And if we sort of simplify this, we get a 1 minus alpha, A1, K1 alpha divided by N1 alpha equal to W1. Then, okay, well, we know a couple of things in the problem. We know that alpha is 0.5. We know that A1 or A in general is 1. The real wage is also 1, right? So we can sort of simplify this even further. So you get 1 minus alpha, 1 minus 0.5 times 1. Then you have here K1. K1 is also actually 1. You know, it was given in the problem. You have K1 equals to 1. K1 equals 1. So you have a 1 raised to 0.5 divided by N1 raised to 0.5 equal to 1. So this basically simplifies to 0.5 divided by N1, 0.5 equal to 1. Or, okay, 0.5 equals N1, 0.5. Then if we square both sides, okay, that gives us N1 is equal to 0.25. So this is the labor demand, okay, the optimal labor demand for the first period. Pretty straightforward, nothing too fancy. Again, this is in proportion labor hours. Okay, so next, we're gonna sort of move on to how the production function is related to the investment and the interest rate, right? So letter A is asking, how does the demand for investment move with the real interest rate? Well, that's a simple, straightforward question. Okay, we have here R. So for A, we have here on the y-axis R, and we have here on the x-axis I, or investment demand, and that's just simply a downward sloping line. Okay, so we know that there is a negative relationship between investment and the interest rate. Okay. For letter B, okay, it's sort of similar to the letter A question. How does an increase in productivity impact the graph, the demand for investments? And of course, as you would expect, it would shift it out simply because of the productivity gains. So if this was the initial curve here in blue, okay, what we would notice is if A increases, we would shift out in this direction here, right? So there will be a shift from that curve to that curve because the demand curve will shift because of the increase in the productivity, right? So that's pretty straightforward. Letter C is also very straightforward. We're given here with actual demand and supply functions. So you have an investment demand equal to this, and supply of saving given to this, and it's asking what is the equilibrium in the asset market. That's very simple enough actually. So you have a couple of equations to consider. So you have the demand equation, which is 1000 R plus I is equal to 30. Then you have 2000 R minus 3S is equal to 10. And because we're in equilibrium, we know that investment must equal saving in equilibrium, right? So investment must equal to saving. Therefore, okay, we can reduce these three equations in these n to just two, right? By substituting one for the other. So we have 1000 R plus I is equal to 30. And then say 2000 R minus 3I, because S is equal to I, is equal to 10. Then we can do some fancy manipulation. We can multiply this by 3. So we get 3000 R plus 3I is equal to 90. And then you have your 2000 R minus 3I is equal to 10. Then that cancels out. Then you're left with 5000 R is equal to 100. Then you divide both sides by 5000. And you get that R is equal to 0.02, right? And then how do you find I? Well, it's simple. You plug in the R into any of the two equations. So you get 1000 times 0.02, okay? Plus I is equal to 30, okay? So you have 1000 times 0.02. Well, that's just a simple calculation. So 1000 times 0.02, that's just gonna be equal to 20, right? So that's just 20 plus, then you have here I is equal to 30. Therefore, I is equal to 10, right? Then if you graph this out, okay, the graph, it should be a simple graph. So R, and then, sorry, and then this is I, technically S2, okay? This curve here represents the demand, so that's 1000 R, 1000 R plus I is equal to 30. And then you have here the supply, which is 2000 R minus 3S is equal to 10. Then the intersection of them would be, okay, R is equal to 0.02. And then you have here I is equal to 10, is equal to S. Okay, so that's our video on the firm's problem, the dynamic firm's problem. And in the next video, we'll go through more problems on about the representative firm. So thank you for your attention, and I'll see you in the next video. Thank you very much.